Welcome to qnawire.
We're told that an object is 0.6 centimeters tall, so I've labeled the object height by y, and that it is placed 16.5 centimeters away from the vertex of a convex mirror, so I called that distance s. We're also given the radius of curvature of the spherical convex mirror, and it's 22 centimeters. But since the mirror is convex, from a reading of chapter 34, you know that the radius is negative. So I just put the magnitude of the radius here. And also, we know that the focal length is determined by 1/2 r. So if the radius is negative, then so is the focal length. And in part A, we're asked to draw a principal ray diagram showing the formation of the image. So I'll do that by blue. First, we can take a ray that's parallel to the optic axis, which is this black line here, and then we know that such a ray will be headed towards, will pass through the focal length, right? It's kind of image, so it'll be reflected such that it appears as though it's coming from the focal length. Another ray that we can draw is one that goes about here to the optic axis, and that ray will be reflected symmetrically about the optic axis, and then we can just extend it back in that fashion. And this is enough to draw an image, but we can do a third one which goes through the center. So this dot here is the center, and that should intersect this point and go down to the center there. So where all these lines intersect will give us the image. So let me put that in red as well. There's our image. So this little distance here is s prime. All right, that's it for part A. Let's move on to part B of the problem. In part B, we are to determine the position, the size, the orientation, and the nature. Nature meaning whether the image is real or virtual. So all these properties of the image are to be determined in part B of the problem. So let's tackle position. In order to calculate the position, we will use equation 34.6, which states that 1 over s prime, so that is the image position, plus 1 over s, which is the object position, is equal to 1 over the focal length. And then we can do a little bit of rearranging, because we want to find s prime, we want to find where the image is. So we can isolate that by subtracting 1 over s from each side of the equation. And then we could put these over a common denominator, the right side here. So that will give me s minus f over fs. So I have 1 over s prime is equal to s minus f over fs. And then I just flip this. So I invert it, or take the reciprocal if you like. And then I'll have fs over s minus f. So this is the equation we'll be using to find the position. And we know that f is the radius of the curvature over 2, and we're given that it's 22 centimeters. So if we divide by 2, then we have 11 centimeters. But note that R is negative since the mirror is convex. So that is negative 11. And we're also given S. So S is 16.5 centimeters. So let's plug in the numbers to find S prime. So we have minus 11 centimeters for the focal length times 16.5 centimeters for the distance of the object from the vertex of a mirror. And then we have 16.5 centimeters minus negative 11 centimeters. And if you just run this through your calculator, then you will find that it's minus 6.6 centimeters, and that is the location of the image. And now to determine the size, we'll use equation 34.7. So from 34.7, that tells us the magnification is minus S prime over S, but it also says that M is also equal to Y prime over Y. So we have that S prime over S is equal to Y prime over Y, which there's a negative sign here. And we want to know the size of the image. So we were already given Y. We just found S prime and we know S. So we can isolate Y prime. So we have Y prime is equal to minus S prime over S times Y. And this will give us the size of the image. So let's substitute the numbers. So that is minus 6.6 centimeters divided by 16.5 centimeters times Y, which is 0.6 centimeters. And that'll give us this part is 0.4 times 0.6 centimeters, and that is 0.24 centimeters. And now we need the orientation. And this is determined by whether or not M is positive or M is negative. And we found M is minus S prime over S, which we actually, from the circle here, that's M, that is 0.4. So that's positive. So that means the image is erect. And now the nature of the image. This is determined whether or not S prime is positive or S prime is negative. So if S prime is positive, then it's real, and if it's negative, then it's virtual. But we found that S prime was negative, so the image is virtual.